So in my previous video I set you a few questions on differentiation using negative powers and roots. What I intend to do in this one is go through these questions with you, show you the solutions and show you how to get the answers. Quick refresher for you though. These were the 4 questions I asked you to do. So calculating derivatives of the following expressions. So the first one was f of x equals cube root of x. Second one was f of x equals fifth root of x to the power 6. Third one was f of x equals 2 over x cubed, and the fourth one was y equals 3 over 2x to the power of 4. Let's have a go at these. So the first one, f of x equals cube root of x. Now remember, for taking the derivative of something, the original function always has to be written in the same form. F of x equals ax to the n. Now the a at the start is a coefficient. Now sometimes they don't get that, sometimes they do. We have to bear that in mind. So for this one, what I've got to do is use my rules with roots in order to write these in this form. Now think back to National 5. We refreshed our memory of these in the original video and how we write this. And that's got to be our first step. So cube root of x, that gets written as x to the power of 1/3. Now that it's written in this form and it's written as f of x equals ax to the n, we can take the derivative. Now remember, in this case, a is just 1, so we can ignore that part there. Take the derivative, and it's the exact same set of steps. Power down, reduce the power by 1. So our power down comes down in front, 1/3, x, and then 1/3, and we take away 1, minus 2 over 3. And that's how we can leave it. If it asks for a positive in this, we can change it about, but at the moment we can just leave it like that. Second one was f of x equals the fifth root of x to the power of 6. Again, hark back to your National 5 rules of Surs and indices work. We have to write that in this form to start, so we have to begin by looking at these and thinking how we change this into that form. So to do this, fifth root of x to the power of 6, we write that as x to the power of 6 over 5. So we've changed it into the correct form that we want. Then, it's just taking our derivative and writing it out as we need. Now remember, it's the same steps. Power down, reduced by 1. So in this case, it's 6/5, the power comes down. We then take 1 off of 6 over 5, and we get left with a fifth. So in this case, 6/5 x to the 1/5. So for those ones, nice straightforward way to bring them in. This one, number 3, f of x equals 2 over x to the power of 3. Now remember, over x to the power of something, we bring it up, but the power becomes negative. So if we think back to our 1 over x to the power of a, we're able to rewrite that as x to the power of negative a. Think back again to your indus work from National 5. So we have to do it like this. Now remember, if the number's on top, that becomes the coefficient of this part here. So 2 over x cubed, we rewrite as 2x to the negative 3. It's only different if there's a 2 in the bottom. You'll see how that comes about in the next example. Now that it's written like this, I can just take my derivative as normal. So it's got a coefficient, so we start by writing that down. We then multiply it by the derivative of this part, and that's still taken the same way. Bring the power down, so I get negative 3x, and then we reduce the power by 1. So negative 3 taken by 1 is negative 4. Watch at this stage, though, quite a common mistake is negative 3 goes to negative 2. People just forget in that brief moment how it works. Just don't make that silly mistake. We then simplify it. Negative 6x to the negative 4. Job done. Now the fourth example, y equals 3 over 2x to the power of 4. Again, we have to transform it using this rule. Now, remember, if there's a number on the bottom, so it's a direct coefficient of the x to the power here, that stays on the bottom. So our coefficient for this one is 3 over 2. It's not bringing the 2 up and then doing 3 times 2 to get 6. Again, a common error we sometimes see. That stays on the bottom. When we shift the x up, this 2 is not part of it. It stays there. So we get 3 over 2 x, and when we bring it up, the power becomes negative to the power of negative 4. It's then a case of working it through. Now it's y equals, so in this case we have to remember it's dy by dx, not f dashed of x. And again, same set of steps. Write down our coefficient, and then take the derivative. Bring the power down, so it's negative 4 in front. X, reduce the power by 1 to the negative 5. We then simplify this here, so 3 over 2 times negative 4, well that's negative 12 over 2, which simplifies to negative 6x to the negative 5. So right there is your dy by dx. So they're all done the same methods as we would do in the first one. Once we get it written in this form here, we're able to take the derivative using the exact same set of steps. The big part comes in getting it written in that form. Always remember ax to the n. That right there is our derivative golden rule. Once we get it written like that, it's very easy and straightforward to take the derivative of any term.